This video is going to demonstrate taking a fraction of a fraction using a model. This video corresponds to lesson 4.2 in our discussion of multiplying of fractions. You might have remembered during a lesson we were talking about taking fractions of fractions. And in this video, we demonstrate using the model. So, for example, my grandma's cupcake recipe makes 24 cupcakes. I only want to make half of that, so I am going to use only half of the ingredients. If the recipe calls for 3/4 cup of sugar, how much sugar would I need? And this is a real-world problem. This happens all the time with your family members. The recipe has a certain amount of ingredients, and if you follow the recipe and add in all the ingredients, it usually tells you how much that recipe would make. So if I add up all my grandmother's ingredients, I'm going to make enough for 24 cupcakes. But I don't want 24 cupcakes. So one of the strategies my grandmother actually taught me was if you want to only make 12, we could just cut the recipe in half. But in order to cut a recipe in half, you have to cut every single one of the ingredients in half. And the ingredients aren't always whole numbers. It's not always going to be 1 cup of sugar or 3 eggs that we could easily do. This recipe calls for 3/4 cup of sugar. So I need to take half of 3/4. I wonder what I can do. What is 1/2 of 3/4? Why don't you take a minute to think about how would you demonstrate taking 1/2 of 3/4? I know in class some of you used fraction strips or fraction tiles, and you were looking at 3/4 pieces, and you tried to cut those in half. What would that be? Well, if you don't have anything in front of you to help you figure out what 1/2 of 3/4 is, you could always draw a model. So in front of me we have a square, and that square is going to represent the sugar. It's going to represent 1 whole cup of sugar, but we don't have a whole cup of sugar. We have 3/4 of a cup of sugar that we want to cut in half. So I'm going to demonstrate that by cutting this square into fourths. And by doing that, I can cut it in half, and then each half I can cut again. Now, it doesn't have to be perfect because it's just a model, and we understand that we have here 4/4 now. If you use graph paper, that actually really helps you stay neat. But I've just cut this cup of sugar into fourths, and I know I have 3 of them. So I have 3/4 cup of sugar. And I want to take this 3/4 and I want to cut it in half. And I can do that by taking it and cutting it in half this way. And I want to put in 1/2 of those 3/4. So here I'm going to shade in 1/2 of those 3/4. And I noticed that when I took 1/2 of the fourths, I all of a sudden got these kind of smaller rectangles. I've cut this 1 cup into, let's count, 1, 2, 3, 4, 5, 6, 7, 8. When I take fourths and cut them in halves, I've got eighths. How many of those eighths are both shaded in red and blue? And we can look here and we can see that we have 1, 2, 3. When I take 1/2 of the 3/4, I'm actually left with 3/8. Let's look at that one more time. Here I have my 1 whole cup of sugar. Normally I would have 3/4. So I'm going to write 3/4 at the top of this square, and I'm going to cut my square into equal fourths. And I'm going to shade in 3 of them. And then I want to take 1/2 of these 3/4. So I can actually just cut this square in half going down this way. And I can shade in half of it. And when it's almost like I'm cutting out half of those 3/4. So when I take away 1/2 of the 3/4, I'm left with what I just circled, which is 3 pieces. But each piece, as I'm circling here, this piece is not equivalent to a half. It's not equivalent to a fourth. This little piece is now an eighth. And I have 1, 2, I have 3 of them. I have 3/8. So I'm going to put in 3/8 of a cup of sugar, not 3/4. So if 1/2 of 3/4 equals 3/8, in class we actually noticed a pattern with our numerators and denominators. Do you see this again now when looking at it? You got it. We could actually just multiply 1 times 3 and we get 3, and 2 times 4 and we get 8. And when we talk about multiplying fractions, we're actually not getting bigger. When you take a fraction of a fraction, you can use multiplication of multiplying the numerators and multiplying the denominators to get the new fraction. But you're not really multiplying because you're not getting bigger. We're just using multiplication to get our answer. So when you see questions like 1/2 of 3/4, you could draw a model to prove your answer, or you can jump right to just multiplying the numerators across and multiplying the denominators across, and you'll get the same answer as the model. Let's try another one. If I wanted to take 2/3 of 1/4, I know the of can mean multiplication. So I can cross the of out and make it look like multiplication. And I can multiply 2 times 1 and get 2, and 3 times 4 and get 12. How do I prove to you using the model that 2/3 of 1/4 is 2/12? Well, watch. I'm going to write 2/3 times 1/4. This denominator of thirds is going to tell me how to cut this square vertically. And I know that it's thirds, so I'm going to make thirds. So here's my 3 equal pieces, and I'm going to shade 2 of them. And I'm going to take 1/4 of this 2/3, or 2/3 of the 1/4. So here's my 2/3. And then I see this denominator is fourths. So I'm going to cut, going this way horizontally, my square into fourths. And I'm going to shade how many? You got it. The numerator tells you 1/4. So I'm going to shade 1/4 in. And the answer is where the two colors overlap. When you're taking 1/4 of the 2/3, or 2/3 of the 1/4, you'll see we have 2 pieces that overlap, which matches our 2 in the numerator of 2/12. Where does the 12 come in? Well, when you noticed, when I cut the square into thirds and then cut it again into fourths, these little square pieces here are not equal to thirds or fourths. Let's count them up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 12 equal pieces, and that's where we get our 2/12. So if the model is a bit confusing to you still, you can continue to practice the model, but also know that when we're taking a fraction of a fraction, you can use multiplication, multiply the numerators across, and multiply the denominators across, and you'll get the same answer. But the model is just a way to prove to you what we mean when we say we're taking a fraction of a fraction. Okay, we're going to try one more. And remember, this is a video, so you can always pause it, you can rewind it, and you can watch it over and over and over again. So 1/3 of 2/5. Well, we're taking a fraction of a fraction. We know we can use multiplication. So of always means multiplication in this instance. 1 times 2 is 2. 3 times 5 is 15. So I know my answer is going to be 2/15. and I'm going to have 2/15 in my model as well. I always take the first fraction and I put it on the top of the box. 1/3. I make my corner, my little multiplication, and I put the second fraction, 2/5, on the vertical side here so that I can remember what I'm cutting this square up into. So my first fraction is 1/3. So I'm going to slice this square into thirds. I'm going to shade in one of them. The numerator and the denominator tell you a lot about how to create this model. So there's my 1/3. Then I'm going to multiply by 2/5. So I have to cut horizontally into fifths. I use a different color. So 1, I'm estimating here, 2, 3, 4. 4 lines will create my fifth. So now I shade in 2, 1, 2 out of the 5 pieces. Now, how many overlap? Let's circle them. 1, 2. So I was correct in the numerator being 2, and let's count up all these pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So as you can see, when we take 1/3 of a fifth, we're actually creating a 15th. So, like we said before, multiplication, when we were using the multiplication, we're not getting bigger because now we're creating little 15ths, not thirds or fifths. But we can multiply the numerator times the numerator and the denominator times the denominator. And we will get the same answer as when we're cutting up our pieces, when we're actually taking 1/3 of 2/5. I hope this video has helped. Don't worry if the model is still a little confusing. We will continue working on this in class, and you'll have lots more chances to practice taking a fraction of a fraction.